Okay, today we're talking about direct variation versus partial variation. And once we get through this, we'll summarize what the difference is between them using both equations, table values, and the graph. So first, let's start with direct variation. There's a mistake in here, so we're going to fix that in a second. Example 1, the new Mazda 3 Sport has gas mileage of 6 kilometers per liter on the highway. This can be modeled by the algebraic equation D equals. So this is where the mistake is. So please change your handouts here. It should just be 6n, like it is in the table. D equals 6n, where D represents the distance you can travel and n represents the number of liters. So distance and liters. So D is distance, n is going to be the number of liters. So number for n. 6 is the 6 kilometers per liter. So if I don't go anywhere, I don't use any liters of gas, then I'm not going to go anywhere. Right? So if I replace 0 for n, I get 0. If I replace 1, so I use 1 liter of gas, how far did I go? 6 kilometers. And so on. So now if I want to graph this, I'm going to look at the two values I have here. So 0 and what it came out to be. When I plugged in 0, what I get? 0. So that's a coordinate. 0, 0. So on the graph, I go to 0, 0, and I plot it. So then the next one we have is 1, 6, which would mean 1, 6. And again, I go to my graph and I plot it, and we're going to have to estimate here, but it's okay. It'll work out in the end. So again, these are my coordinates. So 2, 12. Should be about there. 3, 18. It's about there. 4, 24. 5, 30. Just there. And we can get our line of best fit. But I can also see that 0 and 5 are right on the dots. So that's pretty good. And we can assume that the pattern is going to keep going. So if I go over 5, I would go up 1, 2, 3, 4, 5, 6. So if I do that again, over 5, 1, 2, 3, 4, 5, and up 6, 1, 2, 3, 4, 5, 6, I would end up right there. So I can put a point right there. 1, 2. And draw a line. So use a ruler. Draw your line. Okay, so we have an equation up here. We have the table of values, and we have a graph. So I'm going to show you the next example and come back and we'll talk about what the similarities are and why, or what makes both direct variation. So Duca Mobile Company does not charge any monthly fees, but charges 25 cents per minute of cell phone use. So model this scenario algebraically. So if we have the cost per month, it's 25 cents per minute, and that's it. So it's 25 cents a minute, which is your rate of change, and there's no initial value. So if you don't use your phone, it doesn't cost you anything. So this will be our number of months, and this is C, and our equation is 0.25 m. So let's do 0, and I'm going to use the values in the table. So if I don't talk at all, it costs me 0, because 0.25, actually let me do it out, write it out. so you know what I'm doing. 0.25 times 0 is 0. So now if I do 0.25 times 20, that would be 5. So for 40, it's going to be 10, 15, 20, 25. So again, just like in the example above, we have coordinates 0, 0, 25, 40, 10, 60, 15, and so on. And that's what we're going to graph. So 0, 0, 25, 40, 10, 60, 15, 80, 20, 125. And if we wanted to, we could keep going. So we know that it's going over 1, up 1. If we look at the pattern here, over 1, over 1, up 1, right? Over 1, up 1 each time. So we can continue that pattern if we wanted to get more points. Okay, so let's look at the similarities between these two things here. One is the equation. So if I look at the equation for both of them, I have a rate of change, and that's it. No initial value, just the rate of change. And I'm not adding or subtracting anything in the equation. So that's something that's an equation that would be direct variation. Well, if I look at the coordinates on the table of values, I have 0, 0, and I didn't write it out here, but 0, 0. That's the same. So if your table of values has 0, 0 in it, it doesn't have to be the beginning. It can be somewhere, anywhere in between. If it has 0, 0, that means it's direct variation. And the easiest way is to look at the graph. If it goes through 0, 0, the origin, that means it's direct variation. Okay, so what does partial variation look like? The taxi company charges a flat fee of $2.50 plus 35 cents a kilometer. The cost can be found using this equation. So we have C, which is the cost, is our rate of change. So how is it changing? It's 35 cents per kilometer, so 0.35K. And no matter what, as soon as you get in the cab, it's going to cost you $2.50, not 200, the expensive cab, $2.50. So our equation, 0.35K plus $2.50. So as soon as you get in cab, it costs you $2.50, even if you don't drive anywhere. So if you get in the cab and decide you don't want to go where you're going to go and you get out, they're still going to charge you $2.50. So 0 kilometers plus 250 makes 250. So our first coordinate would be 0, 250. And if we keep going now, so 20 kilometers, it's going to be 950, or what did I say? Maybe I should calculate this. 0.35 times 20 plus 250, yeah, 950. And we keep going. $250 is $16.50, and we get $23.50, $30.50, $37.50. So you can see it's going up by $7 each time. So we have our coordinates now. So if we graph it, $29.50 1650, 60, 23, 50, 80, 30, 50, 100, 37, 50. And you take a ruler and connect it, draw your line of best fit. Okay, and again, we're going to come back and look at the equation, the table of values, and the graph, and see what the similarities are. So for Keedy Mobile Company, they charge $20 per month and an additional 25 cents per minute of long distance call. Model the scenario algebraically. So cost is the rate of change. So the per minute usually tells you, anytime you see the word per, usually tells you what it's going to be. So if I know it says per month and per minute, but let's just decide how much it's going to cost for 1 month. So we have the 25 cents for every minute, plus for that month, it'd be $20. Okay, so we're not talking about how many, we don't care about how many months it is, we're just talking about for the 1 month. So the minutes and the cost. So if I don't use any minutes at all, it's still going to cost me $20 to have that phone. And then after that, again, I'm just using the numbers that are in the table. We have to start calculating. So 0.25 times 20 plus 20. That's going to be 25. 0.25 times 40 plus 20 is going to be 30, and so on. Now, if we plot this, our first coordinate here would be 0, 20, 20, 25, 40, 30, 60, 35, 80, 40, 100, 45. All right, so now let's look at the similarities between these two. First, let's look at the equation. So in the equation up here, I have both a rate of change and an initial value. Same thing here. I have a rate of change and an initial value. So we're adding something. As soon as I add or subtract something to the equation, we have partial variation. So that's what you're looking for. Any adding or subtracting. With direct, we only had the multiplication. That was it. Next thing we look for is the coordinate 0, 0. If I have the coordinate 0, 0, that means it's direct variation. But here I have 0, $2.50, or here 0, 20. So as soon as you don't have 0, 0, that's going to be partial variation. The last thing is the graph. If it doesn't go through the origin, it's partial variation. So to summarize, direct variation. As an equation, you would have something like this as an example. In your table of values, you would have 0, 0. Now the rest of it doesn't matter. It could be something like that. But as soon as you have 0, 0, it's direct variation. And your graph would go through the origin. Now for partial variation, your equation would start out similarly, but we would add something, or just to show you, you could subtract something as well. These are both partial variation because you're adding or subtracting. And your table of values, wherever x is 0, y won't be 0. It'll be something else. Okay, now the other ones don't matter, but as soon as 0 does not match with 0, it's not partial variation. Or sorry, it's not direct variation, it's partial variation. And finally, the graph. Would look like that. Okay, it's not going through 0, 0. It could be decreasing. It doesn't matter if it's increasing or decreasing, but it's not going through the origin. All right, so that's the difference between partial and direct variation. So make sure you understand how to recognize it using an equation, a table of values, and a graph.